Welcome to the second part of the electricity and magnetism series. In this part, we are going to learn about the electromagnets. So, without any further delay, let's soar the sky. So what are electromagnets? In the word electromagnets, we can see there are two words, electro and magnets. So by the common sense, we can understand that it is related to both electricity and magnetism. How did this electromagnet get discovered? Once what happened is a Danish physicist discovered that there is a magnetic field getting created on wherever the electric wires are passing through. He then found out that if electric current is passing through a circuit, it creates a magnetic field, or it gives out a magnetic effect throughout its circumference. It is used in different devices like electric bells that we see outside our home, the telephones, the landline phones that is still used in many places, and transistor radios, the radio that where we hear FM radio or the other frequencies. All of them uses the technology of electromagnets. And not only that, electromagnet is also very useful to lift heavy magnetic loads. My dear students, electromagnets are a very important part in this chapter of electricity and magnetism. So, I would request you not to skip the video and watch till the end so you get a complete understanding of the entire chapter. And so far, if you have liked our videos, please go ahead and hit the subscribe button. What is the principle of an electromagnet? Any magnet that functions on the effects of electric current can be called as an electromagnet, and this is the particular property that every electromagnet follows. That is, whenever there is a current carrying conductor or a wire or a cable, it will produce the magnetic effect, due to which we can develop a brand new magnet. So this is the principle of an electromagnet, which is again a very important question. So please note it down. Here you can also see I have drawn a diagram. What is this diagram states? A current carrying cylindrical coil behaves as a magnet. Now this is a cylindrical coil. Now here we have a cardboard that is shaped as a cylinder. Now what we do is we just connect a dry cell, that is a battery, with its positive and negative terminal, take a copper wire, a coil of an insulated copper wire, and we just wound it in the direction that is given in the diagram. If we do that, and what will happen is the dry cell will start producing current which will flow throughout the cylindrical cardboard, and this will create a magnet which will have its north pole at this side and the south pole at this side. If we bring any magnetic substance near this particular circuit diagram, the main thing that you make, what will happen? The magnetic substance will get attracted towards this particular magnet that is produced due to the current flowing from the dry cell. As this diagram is also extremely important, I would request you to draw it in your copies with proper labeling throughout. Any diagram that you are drawing, you should have to label it very well. How do we get to decide the polarity of the magnet that is formed due to the effect of electric current? How do we know that which side would be the north pole and which side would be the south pole? Here it is. Now, the magnetic polarities at the end of the electromagnet depend upon the direction of the current flowing in its coil. in which direction the current is flowing through the coil, that determines which side would be the North Pole and which side would be the South Pole. How do we get to know this? See this diagram very carefully. In this diagram, in the North Pole symbol, you can see the direction is anti-clockwise, as if it is rotating anti-clockwise, whereas in the South Pole's representation, it is doing it clockwise. So in the previous diagram where you have drawn the coil, the end A, there you can see the current is moving at a clockwise direction. So it becomes the South Pole, whereas on the end B, the current is moving in an anti-clockwise direction, hence it has become the North Pole. This diagram is also very important, so again I would request you to draw it on your copies. Till now, if this video has been helpful to you, please go ahead and hit the like button, and please tell us in the comment section that what are the points of this chapter that you want us to cover more. As the exams are coming, I'm always here to help you guys. As electromagnets are extremely useful, so people are finding out ways how to increase the magnetic field that is produced by the electromagnets, the strength of those magnetic fields and its reach as well. There are in general two basic ways to increase the strength of the magnetic field that is created by an electromagnet. The first point is, if you have already seen that while we were making a basic electromagnet, we used a small cardboard cylinder and we have just wrapped a coil around it. Instead of that cardboard cylinder, which was not doing anything but giving a basic support to those coils, what we can do is we can insert a rod of soft iron or steel, as both of them are extremely good and magnetic substances, inside the cylindrical tube. This will increase the strength of the magnetic field a lot. So, and this rod is called the core of the electromagnet. Alright, so if we insert an iron rod or a steel rod, both of which are very good magnetic substance inside the cylindrical coil, automatically the strength of the magnetic field of the electromagnet will increase into a great deal. The second point is to increase the total number of turns in the coil that we are using. So the keyword is by increasing the total number of turns. Suppose you are using a coil and you have just turned it 4 times. It will create a stronger magnetic field rather than a coil which you have turned just twice. Okay, so the number of turns of the coil around the core is very important to increase the strength of the magnetic field produced by the electromagnet. And there is also another point, this is also very important. If we increase the strength of the current which is passing through the coil, then also the strength of the magnetic field produced by the electromagnet can be increased. So by increasing the strength of the current passing through the coil, this will also increase the strength of the magnetic field produced by the electromagnet. So please share this video with all your friends and also watch it yourself as the exams are approaching. This might help you to do a quick revision on the physics topics.